thing we have is, tells us if we have a point P on a circle, oh that's a sad circle, that's embarrassing. Let's try this again. Okay, so here's my circle. And I have some point P on the outside of my circle. The radius of this circle is r. Linear velocity is talking about how fast this point moves. Okay, so if we know just in general, distance is rate times time, right? We've seen that type of formula before. So if you're trying to find the rate, what would you have to do? If I want to solve for my rate, what do you do? Divide by time. Okay, in terms of a circle, the distance you're traveling is the distance around the outside of the circle. So that's your S, your arc length. We use V for the rate. V represents linear velocity. So what you need to know, this is the first formula that will be given to you on tests or quizzes, but you have to know what everything stands for. So S is still the arc length that we've used before. T is time. V is linear velocity, how fast that point is moving around the outside of the circle. All right. Now, I can also measure this speed using something different. If I want to know how fast this is moving, you could measure it in terms of the distance on the outside of the circle. But we could also measure it in terms of the angle, because as you spin around the circle, your angle is moving, correct? So that is what's called this W-looking thing. It's an omega. That's the angular velocity. It's how fast the angle is changing. And to do that, you just take your angle divided by time. When you use this, what do you think has to be true about theta? Has to be in radians. Any formula we use, theta always has to be in radians. These velocities, your V, your omega, those are velocities, they're speed. So if you think about speed, like if you're driving your car, it's miles per hour. So your units are going to be something per something when we're talking about these speeds. We can also go back and forth between these. We've seen this formula S equals R theta before, correct? So if I started with the first formula, I told you that linear velocity is arc length divided by time. But arc length is R times theta. And if you look at that last formula, what does theta over t give you? Yeah, that's our angular velocity, that omega. So linear velocity is actually equal to the radius times the angular velocity. V equals r omega is the third formula. If you look in your book, I put the table from the book on this handout, and they have 4 formulas. One of them is just what we get as we're solving for this V equals R omega. So your book has this V equals R theta over T. I'm not going to really use that as a formula. It works, it's just not necessary. So the ones that I will give you on your test are these 3. And that's all we need. They'll give us everything we need to solve. So we already had 2 from the last test and quiz, or last quiz, remember, S equals R theta, and area equals 1/2 R squared theta. So these are the final 3. So they're all given to you. You just have to use them. My recommendation when you solve a problem is to write out what you have. So we're just going to jump right in with an example and see what we can do. Suppose that P is on a circle with a radius 15 inches. What would I write down here? Radius is R, So R equals 15 inches. And ray OP is rotating with an angular speed. What variable is angular speed? The W looking thing is called an omega. It is pi over 12 radians per second. Part A says find the angle. If I want the angle, what am I looking for? What variable do we use for the angle? Theta. So that's my question mark. That's what I'm trying to find. Generated by P in 10 seconds. So what's the 10 seconds?
Your time.
You do need to watch your units. I didn't write down units, and I can show you. Some people like to keep the units within the problem, but you need to make sure everything matches. When I say that, I mean this is 10 seconds, this is radians per second, so we're good. If you had a problem that had one unit in seconds and one in minutes, we have to convert them so they match before we do the problem. Okay. So I'm trying to find theta. It can be helpful if we just think about all the formulas we have. So when you take the test, you'll have a formula sheet. It's going to have a list of them right there. The first formula was S equals R theta. Okay. Do I have what I need to use that formula? No, because I don't have S. Do we have any mention of area here? No, so that's probably not going to be helpful. We have V equals S over T. I'm looking for theta. Is that formula going to give me theta? Okay. We have V equals R omega. Does that have anything to do with theta? No. We have omega equals theta over T. So if I'm looking for theta, these are the only two formulas that have theta in it. So I probably need to use one of those. I don't know S, so I can't use that. Do we know omega and T to use this one? Yes. So this is the formula I'm going to use. I encourage you to write down what formula you're using, especially on tests and quizzes. It kind of helps me follow along and understand how you get to where you're going, especially because sometimes there are multiple ways we can solve a problem. So my omega was pi over 12 equals theta over 10. So if we multiply by 10, we get 10 pi over 12, which we reduce to 5 pi over 6. What are my units on theta? It has to be radians. Anytime you use theta in a formula, it has to be radians. What you get out is radians. You'll notice my omega was radians per second. Omega has to be in radians as well before you can use it in a problem. Another way, if you're struggling with units on these, you can write your units within your problem. So this was pi over 12 radians per second equals theta over 10 seconds. And so then if you multiply by 10 seconds, what happens to those seconds? They cancel, and the only unit you're left with is radians. So if you struggle with the unit piece, you can write them in your problem and see what cancels out. All right. Part B. Find the distance traveled by P along the circle. Distance along the circle, what variable is that? S, my arc length. In 10 seconds. So we still have the same radius and angular speed, the same time. So I need S. So when I'm looking at my formulas, I need to pick a formula that has S in it. So which one do you want to use?
Second.
Okay, we can go either way. If we do V equals S over T, do we have V? No. Could we find V? Possibly. We could use like V equals R omega and we could get V. The first one, S equals R theta. We're trying to find S. Do we have R? Do we have theta? Yes. We can get there with either of these formulas. To use the second one, we first have to find V. So the first one is probably the more direct route here. So S equals R, which was 15. Again, if you like to write in your units, you can. That's 15 inches. Theta, we found in part A, was 5 pi over 6. So 15 times 5 pi over 6 is 25 pi over 3. What would be my units on S? S is arc length, it's a distance, so I've said before, S and R will always have the same units because they're both a distance. So my radius was in inches, so this would be in inches. I wrote 25 pi over 3, didn't I say over 2? All right, part C is find the linear speed. So linear speed is v. So I need a formula involving v. So we can do v equals s over t. We have s, we have t. We can do v equals r omega. We have r, we have omega. So you just pick which one you want to do. Would you rather divide or multiply things? Okay, so if we did v equals r omega, my r was 15. If you struggle with the unit, write your units in here. Your omega was pi radians and 12 seconds. So we get 15 pi over 12, which reduces to 5 pi over 4. Your units, radians are like the extra unit. So if you don't need them, they go away. So when I take inches times radians, that's just inches per second. V and omega, they're both velocities. So their units will always be something per something. V is linear, so it's a distance you could measure with a ruler. So it'll be like inches per second, meters per minute, miles per hour, something like that. Questions on this example? Let's look at another one. So a belt runs a pulley of radius 5 inches at 120 revolutions per minute. All right, radius 5 inches, what would I write down? For what variable? R equals 5. 120 revolutions per minute. Okay, that's, when I look at that, I see it's a rate, something per something. All right, revolutions. What does a revolution mean? All the way around the circle. Is that talking about an angle or an arc length? Arc length is a distance around the outside. So arc length is going to be like inches, miles, centimeters, feet, something you could measure with a ruler. Revolution says we went all the way around. Yeah, it's like talking about 360 degrees or 2 pi radians. So when you see revolutions per something, that is actually your omega. Now, just like theta always has to be in radians, omega always has to be radians per something. So the first thing I'm going to ask you to do is to find the angular speed in radians per second. I already have my angular speed, but currently it's in revolutions per minute. I need to convert it. If you want to change minutes into seconds, what do you have to do? 1 minute over 60 seconds. Okay, if I have revolutions and I want radians, we said all the way around the circle is 1 revolution. And how many radians is that? 360 degrees, which is 2 pi radians. So I have 120 times 2 pi divided by 60. We get 4 pi radians per second. Part B says find the linear speed. Linear speed is what variable? Well, yeah, process of elimination. What does R represent? Radius. What does theta represent? The angle. What does S represent? We had an omega. What is omega? So what's left? V and T. T is time. So V is linear velocity or linear speed. So we're looking for V in inches per second. So think about your formulas. We're looking for V. So my options with V are V equals S over T. Do I have S and T? No, so that's probably not the great one to use. We also have V equals R omega. Do we have R and omega? Yes, so let's use that formula. I want inches per second. So we have to use my radius was 5 inches. Again, you don't have to write the units in the problem, but if you struggle with the units on your final answer, it can be helpful. Omega was 4 pi radians per second. So 5 times 4 pi is 20 pi. Inches times radians, your radians just disappear. So it's 20 pi inches per second. So to use omega in a problem, it has to be in radians per something. Omega, the only options that I might give you, it's either talking about revolutions or radians per something. And if it's revolutions, you have to convert it to radians first. I know this can be kind of confusing, but really guys, if you write out the formulas, if you look at your list of formulas, and you've made a list of what variables you have, you'll be able to figure out where to plug things in. Is that one okay with everybody? Let's look at the next one. Okay, why don't you take a second? I want you to read this problem and see if you can write down any of the variables that I've given you. So write down any of the given stuff. 100.
I put S.
Yeah, this one's kind of confusing. So we have the satellite traveling in a circle, okay? But it's not just like on the outside of the Earth. It's 1,600 kilometers above the surface of the Earth. And then I told you the radius of the Earth was 6,400. So we're actually looking at this big circle here. So the 1,600 and the 6,400 together give me what?
Radius.
The radius. So on this problem, it's kind of different. To get your radius, you actually have to add the 6400 and the 1600 to get the radius of the circle the satellite is traveling around. So this one has a radius of 8,000 kilometers. It takes 2 hours to make an orbit. What's the 2 hours? What does it mean if you make an orbit? Goes all the way around. So what's that telling me? Your angle is 2 pi because you made an orbit, you went all the way around the circle, so you traveled a total angle of 2 pi. All right, so A, approximate the linear speed. Linear speed is what? In kilometers per hour. So my formulas, the ones that have V are V equals S over T. We have T, but we don't have S. Or V equals R omega. I have R, but I don't have omega. So either way, we're going to have to find something before we can use one of these formulas. Which one do you want to use? It doesn't matter, we can do either one. Pick one for me.
Omega.
Okay. So if we want to use this formula, we need omega first. So my options with omega, V equals R omega, or omega equals theta over T. Do we have the information to do that? Yeah. So let's start there. Omega equals theta over T. Theta is 2 pi radians. My time is 2 hours. So we just get pi radians per hour. So now we can do V equals R omega. My R was 8,000 kilometers. My omega is pi radians per hour. So we get 8,000 pi. The units, the radians will just disappear, so it's kilometers per hour. Again, you don't have to write the units within your problem. I was just kind of doing that to illustrate how I get the units that I get for my final answer. So sometimes we may have to use more than one formula in our problem. Are we okay with that one? So part B, approximate the distance the satellite travels in 4.5 hours. So the distance it travels, the satellite's out here, what variable represents the distance it travels? S. What's the 4.5 hours? So my options with S equals R theta, but the theta we had was for a different time period, wasn't it? Because it told us that it takes 2 hours to go 2 pi, so the theta that we used in part A is not the same here, because they're traveling for different amounts of time. Or we can do V equals S over T. Does the speed of the satellite change as it moves around? No. So the speed we found in part A is still the speed here. So we could do the V equals S over T. So my V was 8,000 pi kilometers per hour. My S was my arc length. We are trying to find that. My time is 4.5 hours. So if you're solving for S, you multiply by 4.5. If you write out your units, you can see then that the hours cancel, so S is just going to be kilometers. So we have 8,000 times 4.5. So we get 36,000 pi kilometers. I know these are a little challenging. Are there any questions so far? Let's try a couple more. Find the angular speed. Angular speed is what?
Equals theta.
So we're looking for omega. So my formulas with omega, we have omega equals theta over t, or v equals r omega. But I really gave you nothing here. I said the minute hand of a clock. But haven't we had some problems dealing with the minute hand of a clock before? So here's what we have to do. We can do this first one, omega equals theta over t. We just have to pick a theta and a t that match each other. Now, here's where it gets kind of cool. Depending on how you do this, we all could pick different options. If I'm talking about the minute hand, if I said it travels a distance of 2 pi, what does that mean? All the way around the circle. So what time would match that? 1 hour, if you go all the way around the circle. Or you could say 1 hour is the same thing as 60 minutes. Or 60 minutes is the same thing as how many seconds? 3,600. Did I say if you had to do this in minutes, hours, or seconds? No. So we could all do it differently. That's why your units are so, so important. You just have to pick a nice angle. I said 2 pi, but could I have said pi? If you travel pi, so that's halfway around the circle, how much time has passed? 30 minutes. If I said pi over 2, how much time has passed? 15 minutes. So you just have to pick a theta and a t that match each other. So what angle do you want to use? Pi. All right? And so if we travel pi halfway around the circle, how much time has elapsed? 30 minutes. So then if we do omega equals theta over t, we get pi over 30. What would be my units here? Pi is radians per minute. Okay, depending on what you pick, it will be different. If you did it in terms of hours, you would get 2 pi radians per hour. So you have to just make sure that you are putting those labels there on your answer. All right. Is that one okay? All right. Let's look at a last example. Find S if R is 9 yards, omega is 2 pi over 5 radians per second, and t is 12 seconds. So double check, these are both seconds, so we're good. If one of them was seconds and one was minutes, we need to convert. We want the same units when we do a problem. So we have our R, we have omega, we have t. I need S. So my options, S equals R theta. We have R, but we don't have theta. Or V equals S over T. I have T, but I don't have V. So I'm going to have to do 2 formulas here. Which one do you want to use? Well, yeah, we'll have to get to that in a minute. So you're saying use the V equals S over T and find V first? So we want to use V equals S over T, but I need to find V to get that. So the other formula with V is V equals R omega. So let's start there. If you don't know V, R is 9 yards, omega 2 pi over 5 radians per second. So yards times radians, the radians just disappear, so we get 18 pi over 5 yards per second. So now we have V, so now we can do V equals S over T. So 18 pi over 5 equals S over 12. So we get 216 pi over 5. What would be my units on S? S and R always have the same units. They're just a distance. So 216 pi over 5. All right. So this is a little challenging. Tomorrow we are going to have class time to work on this assignment. I'm probably also going to give you a handout. So here's what we have. We need to do a unit circle quiz. Do you guys want to do that at the end? Want to do that right now?
Sure.
Is that okay with everybody? Trying the degrees, radians, and order pairs like we talked about yesterday. So this assignment is due Thursday. It's like 13 problems. So we'll have, I know some of you have a lot going on tomorrow night, so you might want to start this tonight so that you can wrap it up in class tomorrow and not have to worry about it. Tomorrow, on Thursday, I want to do a quiz as well, because we kind of talked about this at the beginning of the week. It'll be over the sections 3.3 and 3.4. I will make a quiz review for you guys and give you that tomorrow.